Good morning, class. So last time we have completed the part that is the adrenergic drugs and the anti-adrenergic agents. So the agonist comes under the adrenergic agents. They are also called as sympathetic nervous system. So the drugs which are related with the adrenergic or the adrenaline, noradrenaline, they comes under the sympathetic nervous system. So the drugs which are agonists, they are called as sympathomimetic drugs, or they are called as adrenergic agents or adrenaline agonist. So drugs which binds to the receptor, that is the adrenergic receptor, that is alpha or beta receptor, and block these receptors. Such drugs, they are called as adrenergic blocker or anti-adrenergic agents or sympatholytic agents. Lytic means break it down. Okay. So the antagonist comes under the lytic, that is the sympatholytic, and the adrenergic agonist, they comes under the sympathomimetic drugs. Now moving from that, now we are going for the next part of this ANS, that is the parasympathetic nervous system. So this parasympathetic nervous system, that is called as cholinergic system. So this cholinergic system is depending upon the neurotransmitter, that is the acetylcholine. So the drugs which bind to the receptor, that is the cholinergic receptor, and showing the activity similar like acetylcholine, such drugs we are called as cholinergic agents. They are also called as agonists. They are also called as parasympathomimetic drugs. And the drugs which bind to the cholinergic receptor and block the activity of acetylcholine, such drugs they are called as acetylcholine blocker. They are called as anticholinergic agents. They are also called as parasympatholytic agents. So in this way, we nomenclate the different agents which comes under the autonomous nervous system. Okay, so we have seen regarding the nervous system. Okay, in case of somatic nervous system, there is only one ganglia, that is from medulla to directly it goes to the effector cell. But in case of parasympathetic and sympathetic nervous system, there are two ganglia. Okay, so first, here the one neuron is there or one ganglion is there. They releases the acetylcholine. Second, it collects and it goes to the effector part or the effector cell where we require the activity. At that part, these are secreted. They bind to the receptor and that will show the activity. So that is the difference between the somatic and the sympathetic and parasympathetic nervous system. In case of somatic, there is only one ganglia, while in case of parasympathetic or sympathetic, there are two ganglia. So in first ganglia, they release acetylcholine. In second one, in case of effector cell, so it is directly attached to the effector cell. So second ganglia at the effector cell, it releases, in case of parasympathetic, they releases acetylcholine. And in case of sympathetic nervous system, they secrete adrenaline, noradrenaline, that is related with the adrenergic agents. Okay, so in case of these, the first ganglia is short in case of sympathetic nervous system. So suppose this is the sympathetic nervous system. So in case of parasympathetic nervous system, the first ganglia is long. Here there is acetylcholine. This is second one. Here release takes place and it releases the acetylcholine. So this red what I have shown, it is for the parasympathetic nervous system, which is related with the acetylcholine. While this showing by the blue lines, this is the sympathetic nervous system. This sympathetic nervous system having first ganglia is a short ganglia where there is a secretion of acetylcholine takes place, and second one is long where there is a secretion of adrenaline or noradrenaline takes place. But in case of these parasympathetic, at the both ganglia there is a secretion of acetylcholine takes place. Now when the secretion of acetylcholine takes place, this acetylcholine binds to the cholinergic receptor. So there are two cholinergic receptors are there. One is the muscarinic receptor, second one is the nicotinic receptor. This muscarinic receptor are again classified into three types, that is the M1 receptor, M2 receptor as well as the M3 receptor. While these nicotinic receptor, they are classified into NM receptor and NN receptor. So in this way the classification of the receptor comes under the cholinergic agents takes place. Okay. Now the basic information clear. This is the parasympathetic nervous system where there is a secretion of acetylcholine takes place. This secretion of acetylcholine, it binds to the two types of receptor. One is the muscarinic receptor, second one is the nicotinic receptor. These muscarinic receptor, they are classified into three types, that is the M1 receptor, M2 receptor and M3 receptor. While this nicotinic receptor, they are classified into two types, that is NM and NN receptors. So this picture you will get the complete idea of what I have told now. In somatic there is only a single ganglia there. In case of parasympathetic there are two ganglia there. In the first ganglia, in case of both, there is a release of acetylcholine takes place, but in case of parasympathetic, in second ganglia also, they releases the acetylcholine, and this acetylcholine, it binds to the muscarinic receptor, which is the effector organ. But in case of sympathetic, after first ganglia, there is a release of acetylcholine takes place, but after second ganglia, which is associated with the effector cell, it releases adrenergic agents, that is the adrenaline or noradrenaline. Now we will move to the next part, that is the acetylcholine, which is the neurotransmitter which is present in the parasympathetic nervous system. So we will see the information regarding the acetylcholine. Generally this acetylcholine, this is the structure of acetylcholine. If you observe the structure, this structure consists of ester part, okay, as well as it having the quaternary ammonium. So due to the quaternary ammonium, it has difficult, or it is difficult for this acetylcholine to cross the blood-brain barrier. So that's why the drug, that is the neurotransmitter, it is not a good choice to prepare as a drug. आपण acetylcholine हा drug म्हणून वापरू शकत नाही. का वापरू शकत नाही? Because of quaternary ammonium, it becomes difficult for acetylcholine to cross the blood-brain barrier, and if it does not cross the blood-brain barrier, it will not enter into the ANS and it will not show the effect. That's why the drug we cannot give in the form of acetylcholine, as well as it having the ester group. Okay, so as we know that if ester is present, what happens? It can undergo hydrolysis reaction. So when the hydrolysis of ester takes place, it gives rise to the two parts, that is the acid and the alcohol. So due to the hydrolysis of this ester, the duration of activity of acetylcholine decreases. So the peripheral enzyme, that is the butyryl cholinesterase, it can degrade this acetylcholine quickly. So that's why there is not a great choice to give acetylcholine as a drug. आपण डोपामाइन पण बघितलेला आहे इन केस ऑफ अँटी पार्किन्सन. सो अँटी पार्किन्सन इफेक्ट आपल्याला सीएनएस मध्ये लागतो. सीएनएस साठी ब्लड ब्रेन बॅरियर क्रॉस करायला पाहिजे, आणि ब्लड ब्रेन बॅरियर कोण क्रॉस करतं? विच हॅविंग अ हायली लिपोफिलिक ड्रग, बट द डोपामाइन हॅविंग हायड्रोफिलिसिटी, so it is difficult him to cross the blood brain barrier. So similarly in case of this acetylcholine, it is difficult for the acetylcholine to cross the blood brain barrier, and if we give the acetylcholine as a drug, it undergo degradation due to the presence of ester linkage, and that degradation is done with the help of enzyme, that is the butyryl cholinesterase. And due to this part, it is difficult to give acetylcholine as a choice of drug. Then there are different receptors, M1 to M5 receptors. Generally of our use are M1, M2 and M3 receptors. So this muscarinic is obtained from Amantia muscaria. Okay, so if you have played a game called as Mario, तुम्ही जर व्हिडिओ गेम खेळलेला असाल मारिओचा, ओके, तर तुम्ही त्यात बघता मारिओ सुरुवातीला छोटा असतो. ओके, ज्यावेळी तुम्ही एखाद्या डॉलर वर मारता मारिओचं डोकं, ओके, हिअर यू कॅन ऑब्झर्व at that time there is a one structure it comes, and when that Mario eat that structure, its growth takes place. So that structure is nothing but the Amanita muscaria. So that part is similar look like the plant from which we can derive the acetylcholine, and the name of that plant is the Amanita muscaria. Okay, so there are 5 muscarinic receptors. So for important or generally we have to study only the 3 receptors, that is the M1 receptor, M2 receptor as well as M3 receptor. The next part, how the distribution of tissue takes place, or where these receptors or muscarinic receptors are present in different types of tissues. Okay, so the M1 receptor, this M1 receptor is present in the organ called as salivary glands, enteric nerves. In that salivary gland and enteric nerves, the muscarinic receptor which is present, that is M1 receptor. Then M2 receptor, it is present in the heart and smooth muscles. So in case of adrenergic receptor, B1 receptor, it is present in the heart. So similarly in case of muscarinic receptor, the M2 receptor which is present in the heart as well as in the smooth muscles. Then M3 receptor, it is also present in the smooth muscles and salivary glands. M4, it is present in the brain in the diffuse form and the lungs. And M5 receptor, it is present in the substantial nigra in the brain as well as in the eyes. So in this way, the distribution of muscarinic receptor takes place. So it is the important part. You should know where the muscarinic receptors are present, where the adrenergic receptors are present, where the A1 receptor presents, A2 receptors present, B1, B2. So you should know the location of the particular receptor which is present in our body. After that, if you know, it is easy for you to write down the answer and to understand the different drugs and their activities. So similarly, these muscarinic receptors, they are also classified into 5 types, and these are present in the various locations which is present in our body. So M1 receptor, it is present in the salivary glands and enteric nerves. Then M2 receptor, which is present in the heart. So B1 receptor and M2 receptor, which are present in the heart cell or the cardiac cell. Okay, B2 receptor, they are present in the bronchi. So B2 receptor or the drugs which are associated with the B2 receptor, they are given as the bronchodilator in case of asthma. Okay, B1 receptor antagonists, they are given as the antihypertensive agents. So if you know the location of the particular receptor, it is easy for you to find out the therapeutic use of a given drug or where it can bind. Okay, so M1 receptor is present in the salivary glands and enteric nerves, whereas M2 receptor, it is present in the heart and the smooth muscles. Then third one, M3 receptor, this M3 receptor, it is present in the smooth muscles and salivary glands. M4 receptor is present in the brain in the diffuse form and in the lungs. And the M5 receptor, this M5 receptor, it is present in the brain in the substantial nigra and in the eyes. So these are some muscarinic agonists we can find out. So methylcholine, carbachol, muscarinic, pilocarpine. So these are some muscarinic agonists which can bind to the muscarinic receptor and follow the action. So you can find out the drug methylcholine, it is synthetic drug, carbachol is the synthetic drug, bithanicol is the synthetic drug, while muscarine and the pilocarpine, these are natural drugs. These are obtained from the plant resources, and these are the origins, that is they are synthetic or natural. So methylcholine, bithanicol, carbachol, These are the drugs which comes under the part that is called as synthetic drugs. While the drugs such as pilocarpine, muscarine, they are obtained from the plant resources. So they comes under the part that is the natural drugs. Then methacholine, they having very low effect on nicotinic receptor, while carbachol having the high activity on nicotinic receptor. Muscarinic having the no effect, pilocarpine having no effect on nicotinic receptor. So these are the two different receptors. Like alpha receptor is different, beta receptor is different. Like in case of parasympathetic nervous system, the two receptors they are different. That is the muscarinic receptor and nicotinic receptor. Okay, so the pilocarpine, muscarine, these are the naturally obtained drugs. They don't have any effect on nicotinic receptor, so they have the effect only on the muscarinic receptor. While the drugs such as carbachol, methacholine, they are obtained from the synthetics or they are obtained by the synthesis. They having the very low effect on nicotinic, while the carbachol having the high effect against the nicotinic receptor. So this pilocarpine, they having the high permeability to cross the blood-brain barrier, while all other three drugs, it is difficult for them to cross the blood-brain barrier. So they are the low blood-brain barrier permeability. And what are the uses? So methacholine is used as a cholinergic for the asthmatic agents. They are utilized for the asthma. Carbachol, they are utilized in the miosis, in the glaucoma. Muscarine, it is used in the hallucination, while pilocarpine, it is used in the xerostomia. Okay, so just only I am giving you the brief introduction regarding the different receptors, different agonists. In later in the lectures, we will go deeply through what are the agonists, what is the structure, what is the SAR. All these things we will go afterwards detail. But now only I am going through the some introductory part regarding these agents. Methanicol, it is short-acting muscarinic agonist. It is used to treat the non-obstructive urinary retention, that is methanicol. These are some adverse effects. Then Atropa belladonna, it is the Greek god of life, belladonna. They are responsible to dilate the pupils. They contain non-selective muscarinic antagonists, atropine and scopolamine. So the muscarinic agonists कुठले कुठले आहेत? Muscarine आहे, pilocarpine आहे, methanicol आहे, carbachol आहे, methacholine आहे. So these are the agonists. And what are the antagonists? These drugs, these agents, they bind to the receptor and they block the activity of acetylcholine. These drugs are called as the antagonists. So the atropine, scopolamine, these are the antagonists. Okay, so from where they are obtained? They are obtained from the Atropa belladonna. Okay, so these are the non-selective muscarinic antagonists. Then overdose of this agent, they causes a dry mouth, confusion and seizures. This is the atropine. Then the pharmacological action of atropine, which is antagonist, muscarinic antagonist. So in case of heart rate decreases in low dose, at high dose it is increases. In case of lungs, it inhibits histamine induced bronchoconstriction. In eyes, they are calling mydriasis. They reduce the salivation, they reduce the sweating. That's why they are having the side effects like dry mouth because of reduction in the salivation. So that's why dry mouth takes place. They are also reduce the sweating aid. The next antagonist, that is the scopolamine. So generally this drug is used as a motion sickness. प्रवास करताना जो sickness येतो, motion sickness. For that we are using this scopolamine agent. Yes, so scopolamine is effective anti-motion sickness. Okay. they can crosses blood-brain barrier easily. Again, adverse effects are dry mouth as well as drowsiness. Okay, so this is some introductory part regarding the muscarinic or the acetylcholine agonist and antagonist. So I will once again repeat the acetylcholine receptor. They bind to the muscarinic receptor or the nicotinic receptor. Okay, so there are 5 types. Generally for our use we require only 3 receptors, M1, M2, M3, and for in case of nicotinic, NM and NN receptors. Okay, so there are generally the 4 agonists which are well known, that is the methacholine, pilocarpine, carbachol and the muscarine, out of which muscarine and pilocarpine they are obtained from the natural resources, that is from the plant, and they don't have any effect on the nicotinic receptor. While the drug such as methacholine, carbachol, they are the synthetic agents and they are having the some kind of effect on the nicotinic receptor. Then there are other 2 drugs, that is the atropine and scopolamine. These are often from atropa belladonna. These are the muscarinic antagonists. Okay, so they are generally used or they are having such kind of pharmacological action. Okay, so this is about some general information regarding muscarinic agents and the antagonist. Okay, we will see in detail. So we will start with the first part, that is the acetylcholine agonist or the muscarinic agents, or you can say parasympathetic agents, or parasympathomimetic agent. Now the main neurotransmitter is acetylcholine. So this is the structure of acetylcholine, which binds to the muscarinic as well as the nicotinic receptor. So after watching the structure, you can understand it having one ester one, and here there is a quaternary ammonia. So due to the quaternary ammonia, it is difficult for acetylcholine to cross the blood-brain barrier. As well as in case of peripheral, there is one enzyme, butyrylcholinesterase. This esterase enzyme, it causes the hydrolysis of ester part of this acetylcholine, and when it causes the hydrolysis, so they are converted into the acid and alcohol due to the hydrolysis, and hence the duration of activity decreases, and as it does not cross the blood-brain barrier, we cannot give the drug in the form of acetylcholine. आपण acetylcholine हा ड्रग म्हणून देऊ शकत नाही, बरोबर आहे. का देऊ शकत नाही? एक तर तो ब्लड ब्रेन बॅरियर क्रॉस करत नाही, and second thing, due to the ester form, it can undergo ester hydrolysis very easily, and when it undergo hydrolysis, that means it undergo metabolism, and due to this thing, what happens is duration of activity decreases. So due to all these things, we cannot give acetylcholine drug for the treatment of muscarinic agonist or treatment which is related with the muscarinic agonist. Now regarding the SAR of cholinergic as muscarinic agonist, so what will the property of these agents require? So these drugs, the drugs which are giving muscarinic agonist, they should mimic the action of acetylcholine on muscarinic receptor as well as nicotinic receptor, but they produces same effect as acetylcholine but in greater magnitude. So आपला एम काय ड्यूरिंग द SAR, आपल्याला असे ड्रग शोधायचे आहेत की मस्कॅनिक रिसेप्टर किंवा निकोटिनिक रिसेप्टरला बाइंड होतील and they will show the activity of acetylcholine, but it should having the greater magnitude. चा इफेक्ट हा जास्त प्रमाणात असला पाहिजे. तर आपण एखादा नवीन शोध कधी घेतो, ओके, एखादा नवीन शोध कधी घेतो तर पहिल्यासारखीच ऍक्टिव्हिटी पाहिजे पण मॅग्निट्यूड जास्त पाहिजे. ऍक्टिव्हिटी पाहिजे तीच पाहिजे, लक्षात आलं. तो आपण एखादी नवीन बाईक लॉन्च करतो, त्यामध्ये काय चेक करतात, इन सम वी शुड हॅव सिमिलर काइंड ऑफ ऍक्टिव्हिटी. बाईकचा यूज काय, एका ठिकाणाहून दुसऱ्या ठिकाणी जाण्यासाठी. बट सम वे चेक इट शुड हॅव अ ग्रेटर मॅग्निट्यूड इन देअर मायलेज. लक्षात आलं? सेम ऍक्टिव्हिटी बट विथ द हायर मॅग्निट्यूड. फॉर दिस वी आर गोइंग फॉर दी अगोनिस्ट एजंट. पण ऍसिटाइल कोलिन का देऊ शकत नाही? इट कॅनॉट क्रॉस द ब्लड ब्रेन बॅरियर as well as it undergo degradation. So it is difficult for us to give the acetylcholine as a drug because it will not enter into the ANS. It will not produce any kind of activity. That's why we have to develop a drug which having the similar kind of activity but in the higher magnitude. So a general strategy of making agonist is the use original compound so that acetylcholine as a framework. So जनरल स्ट्रॅटेजी काय? कुठलीही जनरल स्ट्रॅटेजी, कुठलाही ड्रग तयार करताना आपण एक लीड मॉलिक्यूल कन्सिडर करतो आणि त्या लीड मॉलिक्यूल मध्ये आपण काय करतो? सम मॉडिफिकेशन्स फॉर द बेटरमेंट ऑफ दॅट ड्रग. सिमिलरली आपल्याला अगोनिस्ट ड्रग द्यायचा आहे, विच इज कोलिनर्जिक अगोनिस्ट. सो वी हॅव टू यूज दी acetylcholine as a basic nucleus. We have to modify some part of the acetylcholine so that it will produces the better effect and they can cross the blood-brain barrier. So here you can observe this is Acetoxy group, this is CH2CH2, that is the ethylene bridge, and finally we having the quaternary amine. So these are the three parts which is present in the acetylcholine. So here you can observe quaternary ammonium group, ethylene and Acetoxy group. So these are the properties or these are the functional group which is present in the acetylcholine. So we have to utilize, we have to modify this part so that the drug can become more active and they can cross blood-brain barrier. So आपण कुठले कुठले मॉडिफिकेशन करू शकतो acetylcholine मध्ये? Okay, so modification of quaternary ammonium group. यामध्ये आपण काय काय मॉडिफाय करू शकतो? So quaternary ammonium group, it is in the ionic form in case of acetylcholine. Okay, it is required for the agonist activity. So that group, that is the quaternary ammonium group मधला जो नायट्रोजन आहे, that we can replace with other elements such as sulphur, arsenic, phosphorus. So सायंटिस्ट ने काय केलं? क्वाटर्नरी अमोनियम मधला हा जो ग्रुप आहे नायट्रोजन ग्रुप, तो त्यांनी काय केला? रिप्लेस केला. कशाने? सल्फरने, फॉस्फरस किंवा आर्सेनिक, ज्याच्यापासून त्यांना सिमिलर काइंड ऑफ स्ट्रक्चर मिळतात. सल्फर असेल, आर्सेनिक असेल किंवा फॉस्फरस. But they found that after replacing these things, it is reducing the activity of a drug. Then second thing, presence of 3-methyl group is needed for the activity. So quaternary मध्ये नायट्रोजन आहे तो 3-methyl ग्रुपला अटॅच झालेला आहे. In CH3, CH3 and CH3. So these 3 CH3 groups are must for the activity. So they found that if these CH3 groups, if they are replaced by higher alkanes or hydrogen, they are decreasing the activity. So two important parts regarding the quaternary ammonium. First one, the quaternary ammonium must be present in the ionic form. If we are replacing this nitrogen with the sulfur, phosphorus or arsenic, then their ionic property decreases, and due to the decrease in the ionic property of this N+, it will reduces the activity. And second thing, what they found that 1, 2 and 3, there are 3 CH3 groups. So they found that these CH3 groups are necessary for the activity. So if one of the CH3 group, if we replace by a hydrogen or C2H5, that is the higher alkanes, they are going to reduce the activity. So it is required to have 3 CH3 groups. So that is must for the activity. Okay, here you can found सल्फर अटॅच केला तुम्हाला अनियनिक मिळणार नाही, पण आर्सेनिक आणि फॉस्फरस असेल तर तुम्हाला अनियनिक मिळेल, बट स्टील इट डिक्रीजेस द activity. So nitrogen is must with the positive charge. Okay, so it must be present. So what is the conclusion from that? Positive charge and nitrogen is needed. Second one, it should be on nitrogen. Third one, this positive charge is present when this nitrogen is bonded with the 4 groups or 4 atoms, then only it is possible. Okay, so what we can see, if R is methyl, so सगळे ग्रुप हे मिथाइल ग्रुप असतील, तुम्हाला active agonist drug मिळेल. If R is higher alkanes, then agonist activity decreases, they produces some kind of antagonist effect. Propyl असेल, butyl असेल, pentyl असेल तर तुम्हाला inactive drug मिळणार. If only one R is ethyl or propyl, their activity decreases. And again, if they are having only one group having hydrogen or and other having the CH3 CH3 groups, then also it will decreases or it will reduces the activity. So main part regarding SAR, regarding the quaternary ammonia is that it should be nitrogen with positive charge and they should have the 3 methyl group in their structure. Next one, change in ethylene group. So as the rule of 5 states that there should not be more than 5 atoms between the nitrogen, this nitrogen and terminal hydrogen. कुठलाही terminal hydrogen घ्या, दोघांच्या मध्ये 5 पेक्षा जास्त carbon group असता कामा नये. So if we change the ethylene group, it may be propylene or butylene, it will decreases the activity. If we include the methyl group in ethylene carbon, it can alter the selectivity. If methyl group is attached at this position, that is the butyl ring, it remains the potency of acetylcholine and becomes more selective to the muscarinic receptor. While if it is attached towards the alpha carbon, it reduces in activity or towards the nicotinic activity, and it becomes more selective towards the nicotinic and the drug cannot be used clinically. Okay, so these are some examples. In case of methacholine, it is on beta carbon, so it is more selective towards muscarinic. In case of this structure, it is on beta carbon, so it is not potent as acetylcholine, and it is more selective towards the nicotinic receptor. So if this CH3 group is present in the ethylene bridge on alpha 1, it is nicotinic receptor selective, while it is present at the beta 1, it is muscarinic receptor selective. Then modification of Acetoxy group. If we substituting acetyl with higher group such as propionyl, butyryl, it will reduces the activity. Sir, R च्या इथं आपण CH3S7, C4H9 किंवा higher alkyls attach केलं, it will decreases the activity. The ester group which is present, it is not mandatory for the activity, but at that position the oxygen atom must be present. So त्या ग्रुपला जरी एस्टरची गरज नसेल तरी ऑक्सिजन आहे तो त्याच पोझिशनला असला पाहिजे. आणि जर एस्टर ग्रुप असेल, इट कॅन अंडरगो हायड्रोलायसिस, सो इट विल डिक्रीज द ड्युरेशन ऑफ ऍक्टिव्हिटी. सो दॅट ester group we can replace with the carbamate, ether or ketone. ह्या सगळ्या ग्रुप मध्ये ऑक्सिजन आहे, so we will maintain the position of oxygen, only we are changing the ester part, that is into the carbamate, ketone or ether, so that it will resist to the hydrolysis or it can maintain the activity. So here carbamate group is there instead of ester, or we can go for the ether linkage, or we can go for the ketone. Okay, so these are some basic parts regarding the SAR of cholinergic agents or the cholinergic agonists, through which we can prepare a acetylcholine like drug which is more potent than the acetylcholine. Okay, so we will stop here. Details regarding all these parts we will see in the next lecture.